Arc welding can be performed using either direct current or alternating current. These days, most welding machines are capable of producing either AC or DC welding current, although there are welding machines that produce only DC welding current. The polarity of a DC welding circuit can be changed by turning a polarity switch if one is available, or by physically disconnecting the welding leads and reconnecting them to the opposite terminals. However, a welding machine's polarity should not be changed while the welding machine is operating. When direct current is used for welding, there are special names for the polarity of the welding circuit. We can use this diagram of an electrode and the metal being welded to show the first type of polarity. It is called straight polarity. In this arrangement, the metal is connected to the welding machine's positive output terminal. The welding machine's electrode is connected to the negative terminal of the welding machine. That's why straight polarity is also called DC electrode negative. Now, we can use the same diagram to show the second type of polarity that's used in arc welding. It's called reverse polarity. When reverse polarity is used, the metal being welded is connected to the welding machine's negative terminal, and the electrode is connected to the welding machine's positive terminal. That's why reverse polarity is sometimes called DC electrode positive. Now, during arc welding, heat is generated at both ends of the arc. So both the welding machine's electrode and the metal being welded become extremely hot. However, the conductor at the positive side of an arc gets hotter than the conductor at the negative side. That's because electrons flow from negative to positive, and the collisions between electrons and the positive surface generate heat in addition to the heat caused by just the flow of electrons. Also, the action of electrons leaving the negative surface tend to have a cooling effect on that surface. This means that more heat is generated in the electrode than in the metal being welded, because of the electrons flowing toward the electrode, which is on the positive side of the arc. Having more heat in the electrode enhances consumption of the electrode. This is important in welding methods that rely on the melted electrode to supply filler metal to the weld. Welding can be performed using alternating current, but the applications are much more limited than welding with direct current. Another characteristic that is sometimes used to distinguish between the various types of welding machines is the type of output that the welding machine produces. There are welding machines that deliver a constant current output, machines that deliver a constant voltage output, and machines that can deliver either a constant current output or a constant voltage output. Depending on the situation, each of these types of output has its advantages. Also, some situations require a particular type of output. When a welding machine is delivering a constant current output, the heat that is being applied to the metal remains essentially the same. This is important because heating needs to stay constant to ensure a good weld. When a welding machine is delivering a constant voltage output, the arc voltage remains essentially constant. Basically, a welding machine that supplies constant current can't accommodate the frequent shorting of the electrode to the metal that occurs in some welding methods. The shorting results in the arc voltage fluctuating between its operational level and 0 volts. Using a constant voltage welding machine enables the arc voltage to remain at its operational level, even during those times when the electrode is in contact with the metal.